Suppose you have a 120 kilogram wooden crate resting on a wood floor. What maximum force can you exert horizontally on the crate without moving it? B. If you continue to exert this force once the crate starts to slip, what will its acceleration then be? So what are we given here? We are given the mass of the wooden crate. (120.0 kilograms). And it's made up of wood, and the floor is wooden floor. Therefore, the coefficient of friction, because it says resting, it's not moving, and that is static, is going to be from table wood on wood, and mu sub s, that will be 0.500. Alright, so what we are asked to find is what force can you exert without moving it? Force exerted without moving it. Alright, so let's sketch the situation here. We have a wooden floor, and a wooden crate is resting on it. So we are going to exert a force. So if you exert a force to the right, then there will be a resistance force, which is friction force, to the left. So what other forces are involved here? Because this has a mass m resting on the floor, therefore there will be gravitational force downward, which is mg. Alright, there will be, due to Newton's third law, there will be a reaction force, the floor acting on the crate, and that will be the normal force, upward, and it's equal in magnitude to the gravitational force mg. Now, the relationship of the exerted force with the friction force is something like this. If you have an exerted force in the horizontal axis, friction force on a vertical one, so every time you increase the exerted force, the friction force will increase linearly until it reaches certain value, and then it starts to move. So that exerted value, Fe, at a maximum, F static max, and then starts to move. Once it starts to move, there still be a friction force, but that friction force is less than this value, and this is schematic representation of it. So this region here is kinetic region. This region where it's varying linearly until it reaches a maximum value is static region. Okay, so now what we are required to find is this value here, which is equal to Fs max. But what is Fs max? In general, the friction force is given as normal times the coefficient of friction. So let's call it maximum here, just to indicate that this is a maximum value, and that will be equal to the exerted force in magnitude but opposite in direction. And this value here is mu sub s multiplied by the normal. Because it's horizontal, the normal is going to be just mg. Plug in the numbers. Mu sub s is 0.500 times the mass, which is 120 kilograms, times the gravitational acceleration absolute value is 9.80 meters per second squared. Alright, and the magnitude is 588 newtons. But notice the friction force is to the left, therefore this will be negative 588 newtons. So what is the exerted force? The exerted force will be negative Fs max. That's going to be negative 588 newtons. And that's 588 newtons. So under this condition, if the exerted force is greater than 588 newtons, the crest starts to move. So the maximum exerted force before moving is going to be 588 newtons. Now B, if you continue to exert this force, meaning the force that you are exerting is going to be equal to Fe, continue that force. So the exerted force is 588 newtons. The crest will be moving and the static friction will be less than that maximum value, it's kinetic region. So what's the coefficient of friction in this case? That's going to be mu sub k. Mu sub k on wood, and the coefficient of friction kinetic is going to be 0.300. And what we are asked to find is what will the acceleration be if you continue to exert the same force. Alright, so what is the net force here? F net is going to be the exerted force, F sub E, this value here, minus F sub K. Okay. Fe is known, and Fk is equal to mu sub K. That F sub K is mu sub K times mg. Alright, and net force is equal to mass times acceleration from Newton's second law. If you divide both sides by m, A will be equal to the exerted force F sub E minus mu sub K mg divided by m. Plug in the numbers. The exerted force is 588 newtons. Mu sub K is 0.3. Times the the mass is 120 kilograms times the absolute value of the gravitational acceleration, which is 9.80 meter per second squared. Divide that by 120 kilograms. That tells us the acceleration will be equal to 1.96 meters per second squared.